4.3 is going to be about solving with a system of equations with elimination. So far 4.1 was graphing, 4.2 was substitution. So now the third one, in 4.3, we're going to learn how to do by elimination. This one's actually not difficult, and like the name says it, we're going to eliminate. We're going to try to cancel things out. So let's take a look at an example. Solve the system by elimination. So I'm trying to find the x and the y value that makes these two equations true. If you look at the x's and the y's, if we combine our like terms, what I'm trying to do is that I combine my like terms and one of them cancels out. If I combine the x's, x plus x, I'm going to get 2x. If I combine the y's, that one cancels out. When I combine the 5 and 3, I get 8. So 2x equals 8. Let me divide both sides by 2. And x equals 4. Once again, when you combine them, what we're trying to do for elimination, when we combine our like terms, one of the letters cancels out. So that's why we call it elimination. Now to solve for y, I'm going to plug this x value into any of these equations. Just to choose one, I'm going to choose the first one. So I'm going to write that one, but instead of x, I'm going to write 4. So I have the 4 plus y is equal to 5. Let me move the 4 over, so I get that y is equal to 1. So my answer, my solution should be 4, 1. Remember the x value first and then the y value. So once again, the coordinates 4, 1 are the values are going to make both of my equations true. And if we check it, I have the 4 plus 1 is equal to 5, which is true. I have the 4 minus 1 is equal to 3, which is true. So this is how we do elimination. We want to combine our like terms and one of the letters cancels out, right? It eliminates itself. The only bad thing though is that when we have some of these, if I combine the x's, I get 7x. If I combine the y's, I get 5y. So none of them cancels out. So what we have to do in this case is either multiply one equation or multiply both equations. What we're trying to see is that if I want to cancel the x's, 2 and 5, I can make them into 10. And the way I'm going to make it into 10 is I'm going to multiply it on top everything by 5. Because 5 times 2 is going to give me 10x. Now let me take a look at my second equation. Let me multiply everything by 2. In this case, actually a negative 2. It might seem like right now that 5 and a negative 2 are like random numbers. Let me just multiply everything on top by 5. Let me multiply everything on the bottom by negative 2. And I'll explain exactly why I'm doing that. So once again, multiply everything by 5. I have 10x plus 15y is equal to negative 75. On the second equation, let me multiply everything by negative 2. I get negative 10x minus 4y is equal to negative 2. Now, when I combine my x's, it's going to cancel out. So once again, my goal was I want to cancel out the x's. I can make 2 and 5, I can make both of them into a 10. Multiply 2 by 5, multiply 5 by 2. Notice how one of my numbers has a negative sign because I wanted one of my 10s to be negative. Because now when I combine the x's, 10 minus 10 equals 0. Now on the y's, 15 minus 4, I get 11y. Negative 75 and a negative 2, I get negative 77. Let me divide both sides by 11. So y must be negative 7. Now to solve for x, use any equation. Either these two equations that we just came out with, or these two, which were the original equations. It doesn't matter which equation you use. Just to pick one, I'm going to pick the second equation. I'm going to choose 5x plus 2y equals 1. Instead of y, I'm going to use negative 7. So I have 5x plus 2 times a negative 7 is equal to 1. So I have that 5x minus 14, right? Because 2 times negative 7 is a negative 14. This is equal to 1. Let me move the 14 over. Obviously, switch the sign. I have the 5x equals 15. Let me divide both sides by 5. I get that x is equal to 3. So my answer should be 3, -7. It doesn't matter which letter we solve for first. In my parentheses, I have to put the x value first. Okay, let's take a look at another example. If I combine my x's, I get 6x. If I combine the y's, I get 12y. So none of them cancel out. So let me multiply this first equation. Let me multiply everything by -2. Because I'm looking at my x, -2 times 2 is going to give me -4. So then they're going to cancel out. So let me multiply once again everything by -2 on the first equation. So I have -4x -8y is equal to -10. Right? Multiplied everything by -2. My second equation, I'm not going to do anything. So let me just copy it. I have 4x plus 8y is equal to -9. Once again, I'm not going to do anything. My goal was to cancel out the x's. Right? -4x and 4x cancels out. The funny thing here is that I also cancel out the y's. -8 plus 8, I get 0. Right? Everything cancel out. Now here on the right, -10 and a -9, that gives me -19. When I eliminate all of my letters, so I have no x's, I have no more y, I only have numbers. If I get different numbers on each side of the equation, so like here 0 equals -19, when my numbers are different, I'm going to say this is no solution. So when I don't have any more letters, but my numbers are different, this is going to be one of the special cases, and I'm going to call it no solution. Let me take a look at my other example here. Let me multiply it on the first equation. Let me multiply everything by 3, because that way I get 9x minus 3y is equal to 12. The second equation, I'm not going to do anything. Let me just copy it. -9x plus 3y is equal to -12. If you notice, I multiplied the 3 to make it 9x because I wanted the x's to cancel out. When I combine my like terms, 9x minus 9x goes away, right? 0. -3y plus 3y is also 0. So I have nothing on the left, so that means I have 0. On the right, 12 minus 12 is 0. So here, when I have this thing, I have the same number, 0 is equal to 0. I'm going to call this infinite many solutions. Now, let me explain the difference of these two special cases. Here, no solution, right? When my numbers are different, we call it no solution because we cannot find an x and a y value that are going to make both equations true, right? It is impossible. If we did this by graphing, we're going to have two lines that are going to be parallel and they will never intersect. I know special cases in substitution, we saw it. Different numbers, we call it no solution. So, but once again, what this means is that we will not be able to find an x and a y value that will make both equations true. We might find an x and a y value that make one equation true, but not both. Now here, if we were to graph my example B, if we were to graph them, I'm going to get the exact same line. So one line is going to overlap the other. So it is the exact same line. So I'm going to call this infinite many solutions because any point on the line will make both equations true. Right? There's many points, infinite many points, so that's why we call this infinite many solutions. What I do suggest from these three sections, 4.1, 4.2, 4.3, it is that you become very, very good at one of the three cases. Once again, graphing, substitution, or elimination. You become very good at one of them. And if I come and I ask you, solve this by whatever rule, let's say you guys are good for elimination, but I ask you to solve it by substitution. If you solve it by elimination instead of substitution, you will get the exact same answer. Right? These three things, the 4.1, 4.2, 4.3 sections, just gave you different ways on how to solve the two equations. Whichever method you use will work for any of these two cases. So once again, become very good at one of them, and then once again you can solve it always using that method. Elimination will be the method I would kind of suggest you guys become good at it, because in Math 1060 you guys will be using it a lot. Notice how here we're solving for two letters, X and Y. For Math 1060, you guys are gonna, there's one section when you guys are gonna solve for three letters, and elimination will be very, very useful then. All right, good luck.